algebraic thinking. Some of you might be thinking algebra in elementary school, that's way too high for them. Well, they've done research and shown that students as young as kindergarten can experience algebraic thinking and deepen their understanding prior to when they learn algebra formally, say in middle school. So you may think of algebra as a high school concept, but algebraic thinking starts very young, as early as kindergarten, with our whole number ideas of what number plus 2 equals 5, or we can draw it algebraically or symbolically, a square plus 2 equals 5. Students use algebraic thinking when they're solving these types of problems. We start formally defining variables in upper elementary grades. The first activity I want you to do is to look at this puzzle. It's called By the Shapes. This is a great activity to get students thinking algebraically. On the left-hand side, there's an explanation of how the activity works. I got this off Teachers Pay Teachers, and it's a really nice activity. So you get all the supplies with the Teachers Pay Teachers. You place the By the Shape mat on the document camera or a transparency on the overhead. You show all 4 demonstration cards. That's the ones on the right there, right here, with the clues covered. Explain they're going to determine the number of counters that go into each shape. So you ask a question, do you know how many go into each shape? And so like how many for the triangle, how many for the square, how many for the circle? Probably the kids won't know, they're just guessing. So you reveal the first clue. First we're going to reveal this clue in the top left where it's triangle plus circle equals 7. And the kids will express that the sum of the circle and triangle is 7. Then you show the bottom right clue where it says triangle equals 3. So now they're going to start using their thinking and say, if triangle equals 3, I can use the first card to figure out that circle must be 4. So that's an idea of substitution. They know that the triangle now represents 3 counters, so then they want to know how many the circle would represent. So you put the 3 counters in the triangle and the 4 counters in the circle. Ask, is this okay? The students will agree with you. Then you show the top right clue where it says square equals circle plus circle. And ask them, what do we now know? So they can say, oh, they know that 8 goes in the square because each circle represents 4. So 4 plus 4 equals 8. Then you can show the final clue. Ask students to think about this clue and then discuss it with their partner. So triangle plus square equals 11. Well, they know that triangle is 3 counters. They know a square is 8 counters. So 3 plus 8 equals 11. So this is a great activity. There's lots of puzzles you can do. And here's further instruction. I really like the alternate activity where you randomly assign a different problem to each group of students and allow them to prepare a presentation for the class about how they solve the problem. That really practices MP3, construct viable arguments, and critique the reasoning of others. You have this shape to do too, and you're going to complete the activity. I want you to think about, after you complete the activity, how this helps with algebraic thinking. What algebraic topic does this connect to way later in middle school? It connects to systems of equations since the solution must be true for all the cards in the puzzle. So an activity you can do very, very young can help them with a concept that's much higher with systems of equations. Let's talk variables. What are variables? Well, there's 2 basic definitions for variables. The most common one that people think of is a placeholder. A placeholder is a letter that represents a specific value. That value remains unchanged based on the confines of the mathematical statement. So for example, the price of a large 1-topping pizza at Papa John's on December 1st, 2019, that's just going to be a single value. That's not going to change. Or another definition is a changing value. So a letter that represents a quantity that may change within the context of a mathematical problem. For example, the value of the stock market. That's going to change. You're going to complete a card sorting activity about fixed versus changing quantity. So a placeholder versus a changing quantity. The next thing we need to come to after we understand what variables are is what are our criteria for defining a variable. Now, a lot of students get lazy and skip this, and they're like, oh, everybody knows what my variable represents. But that's where a lot of confusion comes into play. So typically, we use a single letter to represent the variable quantity. Many times we use a letter that makes sense to the meaning of the quantity, like T for time or W for width. So here's the 3 criteria for defining a variable. Number 1, choose a reasonable letter. Again, you can always use X and Y, but sometimes it makes sense to use a T for time or a W for width. The second criteria is a quantifiable definition. That should be the value that you're looking for, right? What are you measuring, or what are you trying to quantify? And then the third defining criteria is the unit of measurement. A lot of times we leave this off. If we're very specific with these when we define our variable, when we're solving our problem, it's much easier. So here's an example. Here's a variable as a changing value. The temperature outside your home is a changing quantity because the temperature changes as the weather changes. So we chose T as our reasonable letter. Our quantifiable variable definition is the outside temperature, and our unit of measurement is in degrees Fahrenheit. So that has all 3 of the criteria in that contextual example. How about the variable as a placeholder? The area of the mathematics classroom is a placeholder because the quantity will be one specific value. So let A represent the area, right? The A is your reasonable letter. The area of the math classroom is your quantifiable variable definition, and square feet is the unit of measurement. If you're teaching algebra, this is a great way to make sure your students are very specific, attending to precision, and they won't forget their labeling. So you are going to complete a defining variables in context assignment on Canvas. Let's talk about misconceptions in algebra. There are a lot of them. Some of you might have had good experiences, some of you might have had bad experiences, but we do need to make sense of algebra. So if you're given the statement that there's twice as many girls in the class as boys, how would you write that relationship using an algebraic equation? So if G represents the number of girls in the class and B represents the number of boys in the class, which equation is correct and why? Should it be G equals 2B, or should it be B equals 2G? Think about it for a few minutes. Pick one and have mathematical justification for which one is correct. When you're finished, move on to the next slide. So G equals 2B, did you pick the correct equation? It is G equals 2B. Many students and teachers choose the wrong one since they're trying to directly translate the relationship. So when it says twice as many girls, they think that must mean 2 times the number of girls. So they choose B equals 2G. That's incorrect since there are already more girls in the class than boys. If we want these values to equal each other, like the equal sign means, we have to multiply the number of boys by 2 in order to have the same number of each. A good way to verify this for yourself is put in a number so you can verify if it works. If there are 6 boys in the class, then if I use B equals 2G and solve, 6 equals 2G, so then G would equal 3. That means there's only 3 girls in the class. Well, that doesn't meet the criteria of the problem where there's twice as many girls as boys. But if we put it in the other equation, G equals 2B, then G equals 2 times 6, then we get G equals 12, which is correct within the context of the problem because there's 12 girls and 6 boys. That means there are twice as many girls in the class than boys. So even though we were doing an algebraic equation, you can put in numbers to make sure it's making sense in the problem. You have an assignment called Notebooks and Pens and School Fare. Students and teachers often misinterpret equations and variables in their meaning. This activity addresses this confusion. Complete this activity and upload your completed worksheet to Canvas. The last thing I want to talk to you about this week is an equation choice board. You can have a menu option for your students for their homework. Allowing students some freedom in their homework can help motivate them to complete it. Here's an example of a menu board for homework of equations. You'll see that some of them are a little unconventional homework, but if it gets your students thinking mathematically and expressing mathematics, that's terrific. All right, I hope you enjoyed the algebraic thinking.